An understanding of mutability and immutability and value and reference types really helps clarify a lot of like little weirdsies that might happen when you're coding. And so I want to talk about those for a second. First thing I want to talk about is value types versus reference types. There's a concept called a value being, or data being passed by value, and another being where data can be passed by reference. The analogy that I like for talking about this is has to do with when you want to like share a website with someone. When you want to, you know, share a web page with somebody. The idea of pass by reference is the way that you would typically share a website with someone, right? If you would say, go to espn.com or whatever, yahoo.com, right? So just by saying that, you essentially told them the address where they can find the website, and then they can go to that website. If the developers of that website ever change that website, it will change for everybody who's looking at the website, right? So that seems natural to us. We call that being passed by reference, because really what you're doing is you're giving a reference to where the thing you're looking for is. The alternative, passed by value, would be like printing out the web page, right? Going to espn.com and printing out the whole page, and then giving like the printed copy to a person. So what happens when you print out the web page and 10 minutes later the developer makes like a huge change to the website? Your paper is obviously outdated, right? It's a copy of the original, but it did not change when the original changed. Okay, so that's what we mean by pass by value. You pass the value to the person, like the current state of the website, but then it doesn't change the actual website. With data types, there are some that are, like some of them are only passed by value, and these are all of the simple data types. So strings, numbers, booleans, and then I think undefined counts as a value type, and I think null counts as a value type. I imagine not a number does, but I'm not positive. Right, so it might, but I'm not positive about that. Passed by reference, the data types that are passed by reference are arrays, objects, and functions. Okay. So these also line up, kind of another term that is used to describe pass by reference or pass by value that aligns with it is the idea of mutability. What does the word mutability mean?
Change.
Yeah, changeable, right? Like mutating means it's changing. Mutable means that it is changeable, right? And something that is immutable is something that is not changeable. Things that are passed by value are immutable. Things that are passed by reference are mutable. And so at this point, I think it's most helpful to just see some examples. So this, I think, yeah, here we go. So we're going to talk about how, let's see first how strings are immutable. So we'll say I have a variable called myString. I'm just lifting this straight from the right up. So that if you're following along, you'll see this about halfway down. So You guys started using constant let, huh? Sweet. You don't have to use var anymore. I hate var. All right, so I'm going to say my string equals pool, the string pool. What will happen? First of all, what's going to happen when I do this? My string at the index of 0. You guys have seen how you can index into strings as if they were arrays. Okay, so that should be a P. Okay, so index, my string at the index of 0 is one of the letters, the first letter. So what about this? I say I want to change my string at 0 to be a C so that we have cool. Okay, what's that going to do? Okay, who thinks that it will be cool? Who thinks it will be pool? You guys. Okay. You guys are pansies. It's pool. Even though I told it that I want the first index of this string to change to a C, it doesn't change. Why doesn't it change? Because strings are what? Immutable. I cannot change a string. It cannot happen. That sounds extreme because you're like, wow, I've changed a string. Like I've added on a string as I've gone. There's a difference between changing a string and reassigning a variable to a new string. Okay, this diagram I think helps. So for example, in this code, I say, oops. Okay, I set a variable called my number and set it equal to 42. And then I change my number and set it equal to 43. Okay, and then I console log my number and it gives me 43. It's tempting to think that I've just mutated the number, but in reality, all a variable is a pointer to some like piece of memory in your computer. Okay, so when I say imagine this circle here is a piece of memory. It's tempting to say, well, I pointed my number as a variable to the piece of memory that's now holding the data 42. And then when I change my number to 43, it instead took the data in that memory and changed it from 42 to 43. But that's not what happens. What really happens is it breaks the pointer over to the address, like the memory where 42 is being held, and it points it to a new piece of memory that now is holding a different piece of data. So for a short period of time, you have double the memory being taken up. And then there's something called a garbage collector, which goes through and it says, this piece of data has nothing pointing to it, so then it just goes and clears it out. And by brief, I mean, I think it's like in the milliseconds range. So this is helpful to know because you cannot change strings. The only thing you can do is reassign a variable to a new string. So what about this? I'll leave that there. If I say let my number equal 2, my num plus plus, okay, what should this show? So who thinks it will be 2? Who thinks it will be 3? Oh, we have more brave souls. It's a 3. But wait, I thought I just said that you can't mutate a number. It doesn't look like I'm reassigning anything here, right? There's no equal sign. What's that? But numbers are also immutable, right? But what is plus plus short for? It's not this. Okay, what is my num going to be now? Why is it 2? I just added 1 to it. Yeah, I never reassigned it, right? This doesn't mutate my num, it just adds 1 to it. And then the computer's like, cool dude, like you didn't do anything with that, so I just calculated my num plus 1 and then it disappeared into the ethos because there's no, the ether, not the ethos, because there's no, nothing saving it. So plus plus is actually not short for plus 1. It's short for plus equals 1. And plus equals 1 is short for what? Yeah. So plus plus is really short for, my num plus plus is short for my num equals my num plus 1. So now my num should be what? 3. Yeah, now it's 3 because I'm actually reassigning it. I never mutated it, right? The same thing goes for strings. Let's say my name is Jack. And then I say name plus equals the string space flash. Console log name. And I should get what? Jack space flash. Here I declared the variable name. I set it equal to a string, but I did not mutate that string. In reality, I reassigned the variable to what it used to be plus something else. Okay. This is where this seems like pretty, you know, I don't know, once you see it, it's like kind of straightforward, but this is where the gotchas start to happen. All right, so I much prefer to use const for everything I can. I'm using lets because I'm doing some reassigning every now and then. I'm using like an equal sign. So I'm going to say let A equal 30, let B equal A, console log B, set A equal to 40, and now console log B again. Okay, what do you think will display on the screen? I have 2 console logs. Like what's going to show up in the console? So who thinks it will be 30 and then 30? Okay. Who thinks it'll be 30 and then 40? Why not? 30, 30. So let's think about this in terms of mutability and value types. So numbers are mutable or immutable? Immutable, yeah. It really does. If you think about it, it makes sense. Like I can't change the number 30, the you know, the universal number 30. I can't change it into a 31. Like 30 is always going to exist. If you think of it that way, that might help. 30 will always exist. I can't change it.
It's not 40 is the new 30.
40 is not the new 30. Not in programming. I hope 30 is not the new 40 because I'm 34 and that would make me 44. So when I set A equal to 30 and then I set B equal to A, immutable values are all passed by value, not passed by reference. Now remember, passed by value is like my example of printing out a web page and giving it to you, right? When the original page changes, the copy does not change. So when I say let B equal A, I am making a copy of 30. So essentially I have a piece of memory in my computer that is holding the data 30. And when I set A equal to 30, I point the variable A to that piece of memory. When I set B equal to A, it doesn't set a variable that points to the variable A. It sets a variable that also points to the memory that is containing the data 30, if that makes sense. And then when I set A equal to something else, it's like the big arrow from A to the memory address of 30 it just points to a different place. But that doesn't change the fact that B is still pointing to 30, right? So that's the idea of pass by value. It's just like I print out a website for you. It's not gonna, changing the website won't change your copy. The same thing is true of value types and things that are passed by value, which are all immutable objects, immutable data types. So then, what about this? Okay, we've been talking a lot about value types and immutable data. What's our person's name? What was that? What?
The person's name?
Yeah. JJ. JJ, okay. How old is JJ? 22. 225. And what eye color does JJ have?
Purple. Purple. Yeah, I vote for purple.
Purple eyes. That's good enough. Okay, so then I'm going to make a variable. That's our variable person. I'm going to make a clone. I'm going to make a clone of JJ. And now, permission status, person dot age plus plus. And then I'm going to console log the clone's age. Okay, so JJ started at 225 years old, which is the new 30. And then he had a birthday, person.age plus plus. And now I'm console logging the clone's age. Let's think through it. Objects are mutable or immutable? Mutable, and therefore they are passed by value or passed by reference. Reference, which means that when I change the original, what will happen with clone? It's also going to change. So the clone's age is 226. So if you set a variable equal to a variable that's equal to an object, essentially they are both pointing to the same object. And because they're mutable, you can change them in place in memory. That's what you'll hear that oftentimes in like coding challenges too. Sometimes they'll say change in place. That means without having to create a copy of something first. You can change it where it is in its memory without having to do a bunch of stuff. The same thing is true of arrays. If I say like, I have a fruits array, that's an array where the 0 index is the string orange and the 1 index is the string apple. And then I set fruits at 0 equal to the string mango. It actually changed it in place, right? I didn't have to say fruits equals whatever fruits used to be, but now with a different first index. I can literally just change right in place. I can change fruits without having to worry about making a copy of it or doing anything like that. Now this can cause troubles when you're getting into like the applications that you're making later in the class. If you find yourself changing an object or like changing a property of an object, remember, even if you try to quote unquote make a copy of it by setting a variable equal to the other variable, like you're not really making a copy of it. You are changing the original. Okay, the same thing would have happened with the clone. If I had said clone.age plus plus, and then console log person.age. It's also 226 because changing one of them changes all of them. It's the same object in memory. It's pointing to the same thing. Does that make sense? No. It's you can think of it kind of like if I had one of you come up and stand here, and then I had 4 of you stand around that person, and that was like basically you were the variable pointing to that data, and then someone put a blue hat on them. Like no matter who you are looking at that person has a blue hat. Okay, there's one piece of data in memory, but any change that one variable, or in this case one person, makes to the data will change it for everybody who's looking at that data. It's kind of the same idea with pass by reference.
Why would it do that object? Or a stream? I mean, a stream is just how much objects. So why would it work for an object and not just a slope stream?
Yeah, so it has to do with the mutability and immutability. I can't change a string at its core, like I cannot change it from one thing to another in the same place in memory, because it's considered immutable. Excuse me. Because it's considered immutable, and therefore any changes that I need to make to the data, I need to make a copy of it first, and like add to that copy or remove from that copy before it gets like saved. So essentially, it's like cloning, or in the website instance, it's like I printed out the website and then wrote like a new paragraph on it or something. So that kind of took the old version and made a slight modification. Because strings and numbers and booleans are immutable, I have to do it that way. It will always be copied. The value will be copied, and then you modify it as you're saving it. So like, yeah. I'm sorry. Well, so I haven't gotten to the object yet, but actually I think we did it. This one up here. Essentially, even though I'm using the same variable name, I could say like let another num equal what my num is, and then modify it somehow, like make a slight computational change to it. And now I have a new variable that is just whatever my num used to be plus one more. But doing so doesn't change my num, right? My num stays the same. Well, using oh, this is rough with this call. Using the same variable name essentially is like saying, I want to take the old value and modify it, but I don't care about keeping the old value. So that's where it's like, you can just reuse, like recycle the variable name my num and set it now equal to, like change it to be what my num used to be plus one more. Now in an object, because they are mutable, I can change a property. I can reset a property of this to be like KK, and it isn't reassigning person to something else. It's just modifying, because I can. It's mutable. I can modify parts of it. I don't know if that answers your question, but anyway, it's not as important that you have all of this memorized. It's more important that you've been introduced to it. Because I remember, like, I ran into an issue, like one of the first things that I was working on when I started, I was running into an issue that I had caused because I thought that when I set a variable equal to a variable that was pointing to an object, that I was making a copy of it, and I was like safe to then change it however I wanted. And so then I started changing my quote unquote copy, but in reality it's changing the original, and it was like having all this weird behavior. And because I had learned about this, it took me probably like an hour, and then I was like, wait a second, I think I remember something about pass by reference and pass by value, and then I like looked it up and figured out that was the problem.
You said you used the same variable.
Not the same variable name. It was kind of like this. Like I think I had been given an object from an API. Like I pulled down an object, some data from an API, and saved it in a variable. And then I said, like, let's say that variable is called data. And then I said, like, you know, var my data or data copy equals data. And then I started changing the data copy, but it's not really a copy. When I make changes to data copy, it's also making changes to data. So that if I console log data later on, all my changes are there. And I screwed. I had expected data to stay the same.
You said that was an object?
It was an object, yeah.
So if you did want to copy and then trim the object, you would use some kind of method to push all or none things in manually, does that work?
You could do a for loop, like a for loop over an object, but there's there's an official way to do that, and that's capital O object.assign. And this will make a copy of another object without modifying it. And my OBJ, my object, is pointing to a completely different object from another object, right? So if I change another object, it's not going to change my object. If I change my object, it's not going to change another object. This totally separates them, makes sure that they're pointing to two different pieces of memory, even though the data is a mirror, like an identical mirror of it, temporarily. Object.assign can also be used to combine multiple objects together. So if you have one object with a property called A and another object with a property called B, you can use object.assign to sort of like melt them together into one object that has both an A property and a B property. So that becomes helpful sometimes when you're dealing with APIs.
For me personally, I think it would be very helpful if I knew like what keywords could be used in what situation, things like that. Like sometimes, you know, like the option assign. I mean, it's like I don't always know like what's a, you know, like what's a necessary keyword to do certain things.
Yeah, this I don't expect you to know this right now. This is a tangent. And the write-up goes into the terminology. So this will talk about primitives, reference types, value types, mutability, immutability, and all that. So this might be helpful for learning like terminology and stuff, and give you hints as to what you can Google for later if you have a question about it. What's that?
It's tough to Google when you don't know what you're Googling.
Yeah, well, that's why you're here, right? So you don't have to, you can try and then you can get help. Yeah, that's it for a little deeper dive into data types. You can start to see why there's like a college class. You know, usually there's one college class dedicated to data types. Like you learn about data structures and so forth.
So, so basically that's
You have like a method called sign that's invoked, that's part of the object.
A method called what?
Sign. Is that what it's?
Assign. Yeah, each data type has its own constructor, which we're actually going to talk about in a few minutes. Constructor functions. Capital O object, capital A array, capital S string, capital N number, and each of those has a method, it's called a prototype method. And in this case, it's on the object constructor as a prototype method called assign. But you don't need to know any of that right now.